All right, good morning, everyone. I hope we are doing well. Okay, so welcome to our class once again. And this is our senior theory. This is our senior theory class. And the math class, huh? This is our math class as usual. Those of you who are just joining in, take note of the following. One, we have a Google Classroom, and this Google Classroom is this is where we upload our notes and the assignments. Then we also have the YouTube channel where you can go and review the lessons after all this is done. So those of you who are just joining in, please take note of that as we proceed through. Now, as we go on, you'll be required to be joining those classes that you can be able to access the notes as well. Okay. Now, straight away, we've been looking at vectors, and we've done quite a lot about vectors. And in our previous lesson, maybe before we get started, can someone open us up with a word of prayer? Sorry, we had forgotten. Someone to give us a word of prayer before we get started. Yes, Namoli Mary.
Humble ourselves for the word of prayer. Our Father, we thank you for this previous time. We thank you for the fact that you have provided us life. We thank you that we are still living and we are still even singing to you every time and every morning. Father, we call upon you. We call upon you throughout this lesson so that you help us to understand and get everything that the teacher is going to say to us. In Jesus' name I have prayed.
Okay, thank you so much, Mary, for the prayer. Okay, so I was saying that we've been looking at vectors, and in our previous lesson, we looked at collinear. Okay, we looked at the collinear points, and we say the 3 points are collinear on condition that they lie on the same line. Okay, now once they lie on the same line, they are on the same line, how do we prove that they are collinear? We prove by showing that these lines here are what? Are parallel. Okay, so the proof for parallel helps us to also find out if 2 or 3 lines are collinear. So when you prove that they are parallel, then therefore you can come to a conclusion that those 2 lines are those points on that line are also collinear as well. So that is what we saw in our last lesson. And I thank you, those who have been doing the work, please keep on practicing more others. The ones I give you is to make sure that you possibly catch up with the lesson. But when you check through other numbers, please, you can even share with us, maybe through the lesson, you say, I made such and such a question and it was maybe challenging. Then we look through together as a class. So today, we are still continuing with the vectors. That's one thing we should be aware that we are still continuing with the vectors. But today, we are going to look at 2 things, okay? We're going to look at 2 things. One, we are going to look at the proportional division of a line. How is a line divided up proportionally, okay? How is it divided up proportionally? That's one thing That's one thing we are going to look at. Okay. How do we bring up the part of the ratios in our vectors? How do the ratios come about? Then the second thing, we are going to start on vector geometry. That's the other second thing that we're going to start on, vector geometry. Okay, that's the other thing that we are going to focus on. But I want first to look at this briefly, because it's just a small part that we need to, it's just a small concept that we need to get as we try to go through these vectors as well. Now, when we talk about proportional division of a line, we are looking at if you have a line here, okay, and maybe you have 2 points, A and then B, and maybe you have another point C in the middle here, and this line is being divided up into different parts. How do we come up with the ratios? Maybe they say the ratio of A maybe to AB to maybe BC, or maybe they say a ratio of SC to maybe CB. So this is what we are going to, this is where the part of the proportional division of a line comes in. You are looking at how do you compare, okay? How do you compare 2 points to another, to another second set of points, or a third set of points, okay? So this is what we basically look at. Now, in here we say there are 2 ways that you can divide up your line. There is a hand up. Okay, yes, your hand was up. You put it down? Okay, good. Please, if you have a question, you just raise up your hand and then you speak to us, to the class. Or you send a text, or you send a text message through our chat. The chat is open. So we're saying that when we have, there are 2 ways that we can divide up our line. One, we have the internal division of a line. This is the first one that we talk about, internal division of a line. Now, in the internal division of the line, we are considering, for example, points, these 2 points here, the lines, AB. AB is this line here, this entire line. And it is divided up into 6 parts. The 6 parts are, from here to here is 1 part, from here to here is the second, here to here, third, fourth, fifth, sixth. These are the parts that we are talking about. Part 1, so 3, 4, 5, and then 6. Okay, so these are the points that we are having. Now, when you have 2 points, that is such that it is 2 units from A. After 2, it is 2 units. This point C that we are having here, it is 2 units from point A. Okay, and it is also 4 units from point B. So from here to point B, we have 4 units. This is it, 1, 2, 3, 4 from this point here. Okay, so then in the ratios we say that SC, the ratio of SC to AB is equal to 2 to 4. Okay, we are saying SC, from SC there are 2 units, so we put this one, we give this one 2. Then from CB, from C to B, CB, there are how many? There are 4. So here we also put the 4. So therefore, when you put it in a ratio form, this is now the ratio form. When you're introducing those full columns, we now we are working now with the ratios. So meaning, when you talk about ratios, we said the ratio of SC to CB is 2 to 4. Okay, 2 to 4, meaning there are 2 units from A to C, and there are also 4 units from C to B. Okay, now usually these ratios here, I think as we learned, I think in our previous section, that with the ratios you are supposed to reduce down to their lowest form. So when you reduce this one into the lowest form by 2, then by 2 you have 2. So the final ratio will be this one here, of from A to C, C to B. This will be your final ratio. I don't know if we get that. So when you're dividing up the line, this is how the ratios come about. we are looking at points and we are looking at how many units are they from another point. That is how the ratios come in about. Now, from here we conclude. We say that point C is therefore said to divide AB internally, okay? Internally in the ratio of 1 to 2. Look here. Those of you who are saying which topic, Benjamin, we are looking at vectors. Vectors is our topic. And the subtopic, we are looking at proportional division of a line. We're looking at proportional division of a line. Proportional division of a line. This is what we are talking about, but the main topic is vectors. That's what we are looking at. So we are saying that AC is dividing up this line AB internally. Why are we saying internally? Because it is in between these what? These points here. So any point that comes between these points here, we would say it divides up that point internally. That's what we mean. That's the explanation that is there. Okay. We say it divides it up internally. So that's the conclusion we are drawing from here. So if a point P, maybe let's take C, if this is the same point P, you can say point P or point C, is said to divide the line internally in a ratio, maybe you can say S to T, like the other one we said 1 to what? 1 to 2. If the point lies between the what? Between those given points. So when you have your point maybe A, B, okay? So any point that comes in between here, any point that comes in here will be dividing that line internally, okay? So that's what we mean by internal division of a line. Okay, so that's what we mean by that. Then when we moving on, the second part that we are looking at is now the external division of the line. We have also the external division of the line. When do we say that a line is divided up externally? Okay, so it is usually the opposite of internal. So with external, it means that the line is outside. If you have A, B, your point A and B, and there is any, the line extends outside those points. If C comes outside AB, so meaning this will be an external division. But there is something that changes here. So we say AB is divided up into the 6 points. BC, look at BC, okay? BC, this BC is equal to 3 of these. Now, please pay attention on this. It's quite technical now. Now, look at these units. From here to here, there are 2 units. This is 1 and this is 2. But from here to here, how many units do we have? We have 1, 2, 3, 4, 5, and what? 5 and 6. Now, why are we saying it is equal to 3? This piece is equal to 3 of these. It means that when you get these 2 here, you can get them 3 times. 3 times these ones here. So meaning the 2 will be in a form, the 3 times will say, this is once, this is twice, and this is 3 times, okay? And remember, this is also just once, so meaning this one goes in AB 3 times. That's what it means, okay? So that's where we say BC is equal to 3 of what? Of AB, okay? So it's a bit something that you need to pay close attention. I repeat. I repeat on this. So we said that when you have these 2 points, BC, and the BC is, we say it is externally dividing up AB. It means that SC is outside, the BC, the C is outside. So meaning it is 3 times from here to the other. So now what are we doing? So we taking the direction of AB. From A to B, it is positive, okay? But C to B, okay? From C to this B here, it is a negative because we are moving in the opposite direction. So therefore, we say, that's when we are saying SC, okay, SC, look at this SC, it is 9 times. Let me write SC. Why is the 9? How is the 9 coming in? So we are saying this is 1, 2, 3, 4, 5, 6, 7, 8. Actually, it is 8, not 9. It is 8. Okay? It is 8 times. This SC from A up to C is 8. But from C up to B, okay? From C up to B, here we are seeing 2 points here. So meaning the 2 becomes a minus. Okay, the 2 becomes minus because we are moving in the opposite direction. Okay, so literally take note, when we say BC, this will be positive, but when you say CB, this will be what? Negative, meaning you're moving in the opposite direction. So that is how we shall come to, this will be 8 and this will be 2. So when you reduce this down, when we reduce it, do we have 2? Yes, when you reduce this one by 2, you shall have 4 by 2 ones. By 2 ones. So this will be, this is, remember, this is a negative. So therefore, SC, the ratio of SC to CB will be 4 to minus 1. Okay, it will be 4 to minus 1. Okay, Moronji Claire, you have a question. Moronji?
Yes, teacher. I wanted to know. So in this case, they said AB is divided up into 6 equal units, and BC is equal to 3 of these. How come is when you said BC is positive, but you're saying CB now when they have said in the thing is it like a question they are saying BC?
No, BC is this one to this one. Okay. When you talk about CB, it means you are coming from here to this side. Okay. That's what we mean.
Yes.
BC is fine. BC is okay. BC is okay. Okay. But for CB, you're meaning you're moving behind, you're moving backwards. Okay. That's what we mean.
Okay.
You see here, the ratio is C, not B, C. That's why the difference is coming in from. All right. Let me ask Anzoa. Is this Anzoa? Anzoa?
Yes, teacher.
Pardon for me, the one for is internal.
Internal, how?
Yes.
Internal, okay. I'll go back later. Okay, all right. It's okay. I'll get back there at some point for you. All right. So so this is what we are saying. Yeah? We are saying CB, not BC. So when it's CB, it becomes a negative. Okay, that's where the negativity or the negative part comes in from. That's the point. Now, how do we conclude on this? So we say that if we say it is external, it means the line goes outside. Okay, if you have your AB, if you have your line AB there, and then the C comes outside this side, it means it is external division. Okay, meaning when you're moving back, it will become a negative. Okay, this one becomes what? It becomes a negative value. So literally, that is how we are looking at the ratios. Now, in summary, when you look at the ratios, when does it become a positive and when does it become a negative? It is a positive when you are in, if we say AB, yeah, and you're in that direction, meaning you're moving from A up to B. This is what? A positive. But in the same thing, and you say BA, this will be what? A negative, because you are moving in the other opposite direction. So that's when we generate the positive. That's what at the point I wanted to bring on. That's when we get the positive and then the negative part of it. That's how they come about. Okay, so in summary, literally how we are building on our ratios. That's how they're coming about. So now, someone said, I repeat, something external, internal. So we said internal is direct. Internal is direct. If it is from A to C, these are 2 units. Okay, we put 2. Then C to B, it becomes 4 because there are 4 units here. Okay, the units are these 1, 2, 3, 4. Okay, that's how it all comes. That's how we get our division. So when you have and it is between the C, once C is between A and B, it becomes a what? It's internal division. But when it goes outside, if the C is outside this line here, it will now become external. It will become external division. So that's where the differences come in as far as that is concerned. Okay. Okay. I have a query here. Okay. Yahweh, Peter. Peter Yahweh, rather Yahweh, Peter.
Teacher, like on the external part, you said like it's to that 3. How did you divide the, like you went like 1 to 2? So what they're trying to mean that the sum is equal to 3. That's how you're supposed to do.
No, not the sum. The sum, not the sum. We are saying this one goes 3 times into this. This is 1. It's like 1. This is 1. But this one goes 3 times. Because these are 2. It's like when you get 2 times 3. That will be 6. But those will end up 6. But it means that this one will take on 1, 2, 3. It is in 2. Okay? That's where the thing is coming. That's where the 3 is coming in from. That's how the 3 is coming in from. Okay. All right. Please, when your devices are not labeled, it's quite difficult to mention your name. I don't want to call people by device names. You want me to call you Tekino? Okay. If you have your device name, it's quite more clear. All right. Leaving that aside, we shall do more of these examples and we see how it basically works out. Now, let's switch to something here called the vector geometry. Now, this is the last part of vectors. And it's the very last part of vectors. And it really combines all the concepts that we've been looking at, right from addition, multiplication, parallel, collinear. We are going to combine all those ones there and then work out in vector geometry. But there's something we need to look at before we start our calculation. By the way, this one has more of the calculation part of it. More of them are the calculations that we have. Okay. Now, we are saying, I said this one is going to combine all the concepts that we've been looking at. Now, let's first look at what happens in the exams are there next week. Okay, there'll be a communication on that. So, vector geometry. Let's learn something before we do. Usually, it's just something small, then we do the calculations. Now, here, when you have, let me draw some, I hope I have some shape here. Now, when we draw up something here, when we have our triangle here, let me pick up a triangle here, and then we shall be able to see it clearly. Okay. Pick up a triangle here. Okay, I don't have any. All right, maybe let's just draw up one. Now, when we have this right angled triangle, let me draw one here. Maybe we can easily have this. Okay, it's not so quick clear, but I think it's a little. So if we have a triangle here, And this triangle here has a sides. Now, maybe we can say, let's say maybe this is A, this is B, and then this is C. Now, take note from A to B, I'm trying to reproduce this. This is A, this vector A. Then this one is vector B. And also this is vector C. Okay. How do we deal with addition of this? Okay. How do we deal with the addition of this? So in the addition of this, we say, if we have those displacement vectors there, as I've labeled there, now we say that C, please take note of this in the beginning, that C, vector C is equal to vector A plus vector B. Okay. For you to come up with this SC, it's like you're saying SC is equal to AB plus what? Plus BC. Okay, plus BC. That's what we have. I know it is something very simple, but we are going to keep on meeting it at some point. Okay. Now, what happens if you change the direction? If I say, if I'm moving from C to B, it becomes a what? A negative, C to B. But now because I'm moving from B to C, it is positive because I'm following that direction that I've been given, okay? So therefore it will be that, okay? Look at your direction as well. So we have SC from A to C. For me to move from A to C, okay, I have AB to BC, and then I'll be able to come up with that. Now we're saying what happens with the subtraction? With the subtraction, it's like also just like making this. If you make this one a negative, it means we are going to have, if you make this one a negative, it means you'll have C is equal to vector A minus vector B. Okay. It will be vector A. Now, why I bring in the negative, that's when you change the direction. Okay. If it is now the direction is this other side, this one will be what? Will be negative B. Okay. So that's why we are saying that in such a case, meaning now if you want to do away with either the negative or something, so here you can find A. Vector A will be C minus B. You can also get vector B as well. So, but the bottom line is this one here. This is our guiding point here. Okay. From this one here, you can manipulate and get all these other vectors as well. Okay. But the bottom line is this beginning vector. Once you know this one, then you can manipulate through and then you get the rest. So this is what we are talking about here. Okay. So when you do the subtraction, you'll end up with that. Okay. So please take note of this concept. Take note of this concept here. So important as we are going to walk through. May I answer? Let me answer some questions from here before we proceed. About this, about the vector geometry. We are going to dive into direct calculations now, or manipulating numbers. That's what we are going to dive in immediately. I'm waiting for some questions. Yes, Claire. Maranji, Claire. Maranji, please unmute. Hey, Maranji, you're not speaking. Okay, Kylie. Oh, Heidi? Someone called Aban?
Good morning, Master.
Good morning.
Yeah, okay. My question is, okay, I get confused. When do we subtract and when we add during the vector geometry? Can you pardon me?
Okay. What's it? Me pardon me on that. Any other question? Any other question? Any other question? Okay. Now, Aban was asking, when do we add, when do we subtract, and something like that. Now, we add following this direction, following the directions. Okay. If we are moving from this, if it is this direction, this is addition, meaning you're moving in the direction of the arrow. Look at the arrow. Okay. When you want to move in the opposite direction of that arrow, it turns to a negative. Okay. I repeat, when you move in the opposite direction, even in this arrow here, if I move in the opposite direction of this arrow, it means it's going to be a minus. Okay. So if I have SC here, SCB, and I move from C to B, C to A, this will be negative this. But SC will be positive because I am moving in the direction that is required. But the same thing happens here. If I am moving from BC, this will be positive what? Positive B. But if I am moving from this side, from C to B, this will be negative. Okay, meaning I am moving in the direction, in the opposite direction. That's what it means. So that's when we bring in the negative. The negative is the one that does the subtraction. Subtraction, it's not that you either subtract also, but it all begins with what? It all begins with the direction. That's where it all starts from. Okay. Any other? Yes, Moronji. Moronji?
Yeah, excuse me, teacher.
Yep.
Like, if the arrows are not given to you, do you use either of them?
Good. Very good question. If the arrows are not there, what should you do? Now, when the arrows are not there, what you do, you follow. You follow we now follow the what? If I am saying AB, if I say, let me use this one as C. If I say AB, it means this is positive. This is positive. But for if you go and say BA, automatically this one will be what? Will be negative, even if the arrows are not there. Okay? Even if the arrows are not there. So we can follow these ones here. We follow this. I am moving from A up to B. I am moving from A up to B. But if I am moving from B up to A, it becomes a negative. Okay? If I am given, because usually these the items are given at some point, we always give you. So they can tell you as you're moving from A to B or as you're moving from B to A. So if they say, if for you your direction is if what you have been given is AB, it means this is positive. But if you want to use BA, it means you're going to turn this one into what? Into a negative. That's where the different thing comes in. So these arrows don't matter. Yeah? As long as you are given this one here. At times, of course, they matter at time to show you, but at times, most of the questions you're going to meet, they will not be giving you those arrows. Okay? So if they don't give you those arrows, just follow. If you say you're moving from A to B, is that. But if you're moving from B to A, then it is the opposite part of it. Okay, another person. Before we dive into our question directed, good. I think people have got it. Okay, yes, Alvin. Chisasha. Alvin. Pardon? How do you do it? I'm not getting that part of. Well, okay, can you speak louder a little? Can you help me type that question? Because I think your volume is quite too low. Okay. Yes, Claire.
Teacher, they are saying if A, B, and C are the displacement vectors, what do they mean by displacement vectors?
We started by displacement. We need to go back to our part. What is a displacement vector? So by displacement, this is what we have. Oh. Okay, I'll have to move back. Or I'll have to, we shall get time and then we move back to this part. Remember, we started by looking at what displacement vectors are, what column vectors and the types of vectors. Those of you who were around in the beginning, but I'll share with you the notes. Maybe you can get more details as well. Okay, dear members, let me do an example. Just one example. Just one example, and then we shall be good. Here we are. So we've been now. Usually these parts we always given in the form of these geometrical shapes. These shapes here usually they give them to us, and then we are supposed to manipulate from there. Okay. So we are saying in this diagram A above, we have OA from O to A is vector A, and also from O to B, this one is the vector B, okay? And we are also saying 3AD, look at it, 3AD is equal to the AB, okay? And we've been told to get the vector or D in terms of what? In terms of vector A and the vector B. That's what we do have. Okay, so usually we are always told to do our working in, we try to put these displacement vectors in form of these vectors that we've been given. So for example, now here we're told to find OD. Yeah, we're told to find OD in terms of A and B. Okay, let's just walk through here. Here we're here. Okay, so if we are to get our OD, when you check through, if you're to get your OD, so when you look at your triangle there, how would you get to OD? Someone to show us, like if we need to move from here up to here, how would you get there following this? Someone to give us that. Someone to give us. Yes, Lona.
OD equals to OA plus AD.
Pardon, OD is equal to OA
plus AD.
Plus AD. Okay. Good. Does someone have any other? Mwebaza, Eric, do you have any other?
Same.
Pardon?
I have the same.
You have the same. Okay, good. So all of us, I think we do have the same thing. So here we are saying that our vector OD our vector OD, let me try to write this. So we're saying our vector OD is equal to OA is equal to vector OA, okay, plus A plus AD, okay? But we know our OA, okay? Our OA, we said it is equal to vector what? Vector A. But we have a challenge of finding what? Of finding AD first. Okay, when you have a challenge of first finding AD, because in AD, we don't have AD in the form of A and B. Okay, we don't have our AD from here, from A up to D. We don't have it in the form of A, B. So what do? We need to find our AD. We need to find our AD. But remember that I've told us in a question that 3AD is equal to AB. Okay? They said AD, 3AD is equal to what? To AB. Okay? So you realize that in all things as we are moving on, Ronald was saying someone would also get OB plus BD. It is also okay. That's why I was asking for more other options as well. So here we are. So we are saying that if you have, you can also get, someone was saying, you can also say OB plus OB, okay? Plus, he said OD plus what? Let me check through. OD plus BD. OD, OB plus BD. OB plus BD. It is also very fine. Very, very okay. Okay, it is also fine. So here you have your OB already. So your task is to find what? BD. It is fine. Okay. So in our question here, they've told us that 3AD is equal to what? To AB. Okay. So meaning when you divide it through by 3 out of 3, you have your AD as 1 out of 3 AB. Okay. But now what is AB? What is AB? That's another task that we have. What is AB? Someone to tell us, how do you get AB? This is what AB in terms of, remember we are looking at everything, finding it in terms of vector A and then vector what? Vector B. That's what we are aiming at. Okay. So what is our AB? Someone to tell us. What's our AB? Blessing.
AB is equal to AO plus OB.
AO plus
OB.
Plus OB. And what is AO? What is AO? A blessing is gone. What is AO? So she's saying that AB, for us to move from A to B, you are moving from A to O, then O to B. That's what you're saying. Okay. So someone to tell me what is AO? Yes, is it Modest?
It's Mondesi.
Mondesi, yes, Mondesi. What is AO?
AO is the negative of OA, which is negative A.
Which is negative A. Plus what is OB?
OB is B.
OB is B. Thank you very much. Okay, I think we have got the concept here now. Why are we putting negative? Because in our original part is OA, but now we are saying AO. That's why the negative is coming in, okay? That's where the negative is coming in, so it will be minus negative to be a negative. So another person can write it as B minus A. It's the same thing, okay? This is the same as this, okay? Good. So from there, what do? You go and substitute back. We now go and then we do our substitution. Maybe you're going to substitute this one into this one here. Okay. Then after getting this one, you substitute also in the previous one. So when you do the substitution, you'll end up having, when we do the substitution, we shall end up having our AD, vector AD being equal to 1 out of 3 into B minus A. See that? B minus the A. Okay? So this is what we do have. Another person can say it is a B minus A over 3. It is the same thing. Okay. Over 3. It is okay. You can write it that way as well. Good. So from there, we do now another substitution up. So we are going to substitute this one here into what we had started with. Remember, we said our OD is equal to, our OD was equal to OA plus AD is equal to OA plus AD. So what is now our OA? We said our OA is vector A plus this one here. Okay, and this one is B minus A out of 3. Please don't leave your thing in this form here. Huh? Don't leave it like this. You're supposed to remain with only with 1A and then 1B in your equation. So what do? We put this one over 1. Okay, get the LCM here is 3. 3 by 1. This will be 3A plus 3 to this is 1 plus B minus A. Okay, plus B minus A. So when you reduce this 3A minus A will be 2A. So this will be equal to 2A plus B. Okay, out of what? Out of 3. Out of 3. But you can simply, I think it is okay. You can also say 1 out of 3 into 2A plus B is equal to what? To OD. Okay? Okay, is equal to OD. Let me repeat this right from the start. So this will be your final answer. Now, those of you who have worked, who have used the other method, the other one of OB plus DB, is it DB or BD? I think it was BD. Can you also try to work out using this and you see what you can be able to get? Or to first get this, we get OB plus BD. Try to use this one here to see if you come up with the same thing inside. You should be able to come up with the same thing this way as well. Let me repeat. Finally, as we close, we said when we are to get the OD, this is what we have, our OD. We're saying it is the same as, the same as OA, okay? OA plus AB. Sorry, OA, is it OA? Yes, OA plus AD. This is what we have, okay? But in our equation, in the work I've given us, OA is equal to vector what? Vector A. We already know this. But we have a task of finding what? Finding AD. Another thing, please, make use of the information. Make use of the information that you are given. Eh? Don't run off. Always make use of the information you are given here. Okay? Like here, don't again go and say AD is equal to again you see you get confused first. OB. All right. Sorry. I hope we are there. So we are saying that when we have our OA, this is what you have. So our task is to find AD, okay? Of which our AD we have been given some information here. Please make use of the information that you're always given, okay? Don't run into some other information. Make use of the information you're given. From here, you can come up with it. Some days I'm like, okay, so may I have some questions? Some questions here. Let me have some questions. Let me have some questions here. Yes, Rachel. I make Rachel.
Sir, yes, please.
Hmm.
Okay, sir. Like when you put your answer like like 2A into bracket 1 plus B out of 3. Is it also correct? Or
2A
into bracket 1 plus B out of 3.
Out of 3, it is okay, but this will be a more simpler form. It is also fine. It is also fine. Okay. Yes, Claire, Murunji.
Teacher, is this how they always set the questions with only like one number, or do they always involve some more?
Yes, they involve more. This one we've just tried out for one, but there are more that are there. It is not only this one, more others are there. We are going to work out more other questions. Yes, Victor? 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 Abara? Abara Victor? Okay. Yes, Ricky? Ricky?
Can you provide the other question that you were talking about?
Pardon? Pardon?
The other question that we have entertained with as an example.
The question we've used as an example?
Yes, we want to create and we'll find out and we'll do it ourselves.
Yes, I'm going to send it to you. I'm going to send it out. So don't worry about that. Okay. So I know okay. So that's what we are supposed to do as far as this is concerned. We are going to do more examples as far as the vector geometry is concerned. And we will try to do more examples. So don't worry about that. We are going to do more and more other examples. I think you don't have to worry about that. Now I'm going to give you one more for yourself, for you to try out, following the same procedures that I've given you here. Okay, following the same procedures, I'm going to give you some to work out here. And it's just a simple one. It's just a simple one that you're going to work out for me in your exercise. Not this one here. So this is what you are going to work out. So we've been given this and we have been told to find what? We've been told to find BM, okay? To find BM, BM, and also M, N, MN, meaning you're going to draw a line here to join. You're going to draw a line here to join so that you get MN through this, okay? But we are putting them in terms of AB, just as we said, if it is BM, we know it is from B to M. So you can say MO plus OB. Quick as that, I think it's simple as that. Then you also look for this MN. So for it to move from M to N, you can say NT plus TM. Okay. So from here, you find NT, also you also find TM as well. That is what you're going to carry on. I'm going to share this in the Google Classroom so that you do the same thing as well. Any further questions? Yes, Murunji, finally, as we close.
Teacher, I never understood where you got the 2 from.
Where did we get the 2? The 2 was got from here. The 2 was got from here. We're subtracting 3A. Here. 3A minus A is 2A. Got it?
Yes, sir.
Okay. Yes, Claire? We are closing. Okay.
Teacher, for MN, what if when I want to find it, what if I say MA plus? Could you zoom in and I see it clearly? Yeah, for MN, what if I say MA plus AN?
It is okay. As long as you can find this and also find this, it's very fine. Okay, members, I told you with vectors, we are trying to find alternative routes. Okay, that if I want to move from here, what route can I take? Someone can use this one to this one to this one. Another one can use this one to this one to this one. Okay, but at the end of it all, have you reached that destination? That's what we need to look at. Okay, dear members, I want us to stop here for now, and we prepare for the next class. I think it's in a little while, and then we check through. Otherwise, check through the Google Classroom. I'm going to post all the notes, and then this work as well, and you'll be able to work it out. I want to wish you a good week ahead. There is a meeting in the afternoon, so don't forget for your parents and some of you to attend. Finally, Brenda. Okay.
I'm requesting the Google Class code.
Okay. Mr. Dumba, do you have anything before we close? I think we're done. Mr. Dumba? Okay. All right. So thank you so much. And let me wish you a nice week and a nice day.
Yes, Moronji. Moronji, your hand is up. Hello.
Teacher, I wanted to ask, what is it going to be an assembly or it's going to be a meeting?
It's going to be a general assembly. I make Rachel. Yes, Rachel. Yes, please.
No, teacher, I raised up my hand for the last prayer only.
Hey, you want to give us a prayer?
Yeah, the closing prayer.
Okay, then go ahead.
Okay, let's pray. Almighty Father, we thank you for the gift of a new day. We thank you for the lesson that we are done with now. Thank you for the teacher who has taught us, and we have at least picked something from it, oh God. Guide him, protect this organization, oh God, that is supporting us to learn during this lockdown, oh God, Father. Give them, bless their hands, oh God, Father. I pray all this, Lord, believing that you have heard in Jesus Christ, our Lord, I pray. Amen.
Amen. Thank you so much, Rachel.